Hi, this is a response video to a recently published video where a couple of people are exploring a little bit in APL and related languages, speaking about them. And instead of a normal hello world, which is too trivial to get a feeling for a programming language, they do something that they call the goodbye hello world. And they are using mainly GNU APL there. There are a couple of things that are suboptimal, and also GNU APL does not have a whole lot of features that a full-fledged APL system would normally have. I use Dyalog APL, which they mentioned multiple times. It's commercial. It is also available for free, and it's not like they say that it's like a trial version. However, it is a non-commercial and educational license that's entirely free. So let's say somebody has a non-profit organization, they can actually use the full system completely for free. If somebody uses it in a school, educationally, that's also fine. Enough about that. Let's get started. The idea of the Goodbye Hello World is basically that we get a count and then we say we meaning print out hello world, and then we count down with some dots in between, numbers 3, 2, 1, and then we say bye bye on the same line. And then there's some input as well. So this is all made, and that's what I will do as well, as a shell script. And we can take an argument, which is the count. However, we have to also reject invalid counts, things that are not just a number. And we are also able to run the script without giving it an argument, in which case we have to prompt for a count. And if the response to that prompt is invalid, then we have to loop, complain about it, and loop and ask again until we get a proper number. So let's get started. And like they did, I will start by defining a couple of traditional functions, and then we'll take it from there. So I'm going to define a function that has the result C called GetCount, and we're using these dels to do this. So that's what that was called. They asked this question: what is this character called? It's called a del. It's also known as a nabla, but in APL circles, it's generally called del. And we're going to take an argument C. So what I'm going to do here is I'm going to build up, and that's something that APLs often do, small tools, and then I'm going to chain them together to do the whole thing. So getCount is going to take the command line arguments, or a part of them at least, and then it's going to return what the count is, either from the command line, or it will go through the whole loop and asking, and then return the actual count. And then I'm going to write another function that does the actual greeting, writing out the messages, and it takes the count as argument. So we can see how we are going to chain together the result from this function with the argument. It becomes the argument to this function down here. And then with the actual chaining we'll do, so we're going to do a greeting that takes the result of getCount, and this is where we actually start with things. So we need to get the command line arguments. GNU APL has a kind of elegant way to do it. They just have a system name that gives you a vector of the arguments. It's a little bit uglier in Dyalog APL, but it basically comes out the same thing. And that is, we have to enqueue an event. We put it immediately for the event queue, so that's what that code 2 means. And we put the event on the root object, and the actual event that's going to happen is get command line arg. So this returns a vector of the command line arguments, and we don't have this kind of thing with a double dash to distinguish arguments to the interpreter itself and to the program that's running. When we're running in the shell, then a shell script, then simply the first argument is going to be the name of the script that's running, and then any subsequent arguments are the arguments that were given to that script. So we're going to drop one, and then we're going to enlist the remaining arguments. That simply just slams them together. I'm not interested in having them parsed out because we're only interested in one argument, and anything comes after that is not in the scope of this. So this gives us either an empty character vector if nothing was given as argument, or whatever was given as argument just slammed together, and we give that to GetCount. So let's start programming, and this is where immediately in APL, in Dyalog APL, I feel like I have better tools at hand than what you have in GNU APL, and it's not very unique to Dyalog APL either. Other big commercial APLs tend to have this as well, and that is control structures. So I can actually write a while loop, and I have a condition here, which is while the count is empty. So this would only happen if we're called from the command line and we're not given any arguments. It is optional to write the word while here. I can just write end as well, but it's easier to find your way around if you do that. And the capitalization doesn't matter, just making it pretty. Okay, so one condition is that it can't be empty, so then we have to go around the loop. Another condition, and that we're also allowed to write things like this. So a double condition, but it's short-circuiting, so we don't go here if the first one gives us enough of a result. And that is whether all the characters, so all the characters in the count, they have to be digits. And we don't have to spell out the digits from 0 to 9 at all. We actually have that as a built-in name, quad D, that's the digits. And we're setting here in the negative, so we can just look at whether the characters are member of that. So for every character, we get a 1 or a 0. And if they're all digits, we are all 1. So that means if we have to keep looping here as long as there's any 0 in this. Of course, if it's empty, then we wouldn't get any zeros, but that's being caught by this condition up here. So if 0 is member of the characters, member of the digits, then we need to go and loop. And then we will need to prompt. So we'll write the prompt out, countdown, and then we can put it on the same line here. We get the value, the input. However, going around this loop, there's the case where we have given something that's bad, so it has non-digits in it, or it's empty. So we want a conditional inside here. So if it differs from being empty, that means we have gotten some kind of input, then we complain that invalid countdown down, and then we also mirror what it was that was inputted, try again, and then a new line after that. And as I type this, I have an auto reformatting I can do as well. So it makes the indentation all look nice and the capitalization as well. So this also means that if at this point the user enters nothing, just a blank, then we don't say it's invalid, we just ask again, which is probably fine. Okay, and then the greeting. So for that, we start off by saying, how is it, world, and hello. And at the end, we want to say bye-bye. And then in the middle, we can loop over all the countdowns here. So we can say for I in, and then the reversed count. And this is where things get a bit interesting, because we want want this, the count, but we want it changed into a number. And in the video, then I mean, it's kind of clever what they do, but it's completely unnecessary. So here's an interactive APL session, or a REPL, and what they do, let's say we have the characters 1, 2, 3. That is, they want to get digit values for these, and they do that by taking the Unicode value of the characters. So that's this, and then they have the Unicode value of a 0, and they need to subtract that. Like that. So that gives us the individual numbers 1, 2, and 3, and then they construct the number. They need to they reduce on it, so they need to do it in reverse because we start reduce from the right. And what they do is they take the previous value and then they add it to the next value, which is multiplied by 10, and that gives us the number. And this is very clever usage of APL, but it's actually completely unnecessary. This whole thing here with the reversal, that's actually a base evaluation which APL has built in and has always had built in. So in fact, once we've got these numbers 1, 2, 3, we can just evaluate that in base 10, which now it's been reversed. We don't want to reverse that anymore. So evaluate that in base 10. We can use this to evaluate in any base. But even finding the digits like this, the digit values, is also unnecessary. Firstly, we could just look them up in the list of digits. Then they're off by 1, but we could adjust that. But remember, at the point when we are ready to convert from text to numbers, we already know that we only have digits and we have digits. It's not empty, which means we can simply evaluate this character vector as an APL expression because the characters 1, 2, 3 evaluate to the number 123. And there is a primitive APL function for that. It's execute, and that just does the trick. So that's what we're going to do here. It's normally not a safe operation to have like an eval inside your code, but in this case we know that it's safe because we know we just have digits. Right. And so inside this loop, we are going to let's reformat this so it looks a little bit nicer. We're going to print, and we want to have 3 dots after. So this is concatenation with permuted arguments. So it goes after the formatted number here. And as I mentioned, we can localize this. So, but it doesn't really matter. There is no scope to pollute. But for good order. And then we're going to have a delay of 1 second. And if I haven't made any mistakes, then this is all that's necessary. Let's save this, and then we jump over to our shell and call run. It asks for a countdown. 2, 1, and bye-bye. Okay, and we can also try run with an argument. And we can try giving it something wrong. It says try again, and we can give it something wrong again. And it will complain, and then we can continue this until we give it something valid. So this is all very nice, using structured programming in APL. However, and it's not the most APL-y. These kind of small if statements, there's really no reason to have those. And the same thing with a for loop like this. It's really not the APL way. So let's see how I might write this as an APLer. For the if statement, it's very common for text-based things like this to use something called compress or replicate. So let's say I have some text. Then I can replicate or the characters here. So I can say I want 2 of each. I can also select which ones I want. So I want 2 of these and 0 of those, 1 of those, none of those, and 1 of those. Right, so we get 2 H's, no E's, 1 L, and 1 O. But if you just use one number, then and the number is a Boolean, 0 or 1, then you can either get the message or not get the message, get an empty vector. And that means we can use this. So we can take this condition and use it here to replicate or compress this entire character vector. So we are going to build it even though we don't need it, but it doesn't really matter here. It doesn't have any significant overhead to do so. And then we compress it. So either we print to the current line no characters at all, including no new line, or we print the whole message. And that just collapsed 3 lines into 1 and might actually read better. APLs will often read this as like on condition of this, then that. And for the for loop, we can do something similar to what they did in the video. So we're going to combine these into a little inline lambda or defen, and we're going to run that on each of these numbers here. So we generate the numbers, and then on that we apply this lambda, which prints out as before, and then waits for 1 second. And that, I think, is a little bit more of an APL way to do it. In fact, we can let's put everything on one line. Then it even reads nicely. Then you can kind of see there's a static thing, and then there's the dynamic thing here, and then there's a static thing again. So let's go and save this and try it again. It should be much the same. Oh, looks like I made a mistake here. Oh, of course, I'm using I. Shouldn't be using I here. Inside the lambda, I should be using this omega. There we go. Okay, let's try it again. Yep, that's good. Okay, now let's try a little bit more of a functional approach to this. So instead of using these, what do they call, traditional functions or thread-fins, we're going to use only lambdas like these, and we're not going to use variables which is going to apply functions. So we can do that, but then we're not going to have loops like this. Instead, we're going to use tail recursion. So how are we going to do that? Okay, first we change this into a function that uses these braces. And then we can see the syntax coloring changed as well because we don't have these keywords anymore. That's not how these lambdas work. And we are not going to do this short-circuiting thing either. Let's just combine these together. So it's an OR. And we are going to use the negative as well. So because we're going to recurse, we're going to go around and around until this is true. And this was, before it was a while loop. So we want to negate the OR here. So we don't want an OR, we want an OR. Okay, so when that's, when those conditions, when neither this one nor this one is true anymore, then we're done. So then we return the count. We have found the count. Okay. Then here we know we haven't found the count yet, so we need to output this message. That can stay the way it is. And then we try to get a new count, but instead of looping here, and instead of assigning, oh, we need to change this as well, right? Because we know that the argument given was the input. or in the first time around the loop, it's from whatever we got from the command line. So we're using omega for that. And then instead of assigning this to a variable, which we are allowed to do in these lambdas, assign variables, but we don't need to do that here. Then this del inside such a function here, it's a recursion. So we just call ourselves on that. And because it's at the very end and we're not using the result further, then we're going to do tail recursion. So it doesn't matter how many times we go around the loop, we're not going to build up a stack. It is tail call optimized. Okay, and greet should be pretty straightforward. And we can simply change this into a function like this, and then changing the c into an omega. Let's reformat that, and we're all set. Let's see if we have made any mistakes. Oh, C, I forgot one more C in there. And it's up here. It should be the argument, of course. There we go. Oops. Save that. And running it. Oh, there you go. It runs. And now, for the final thing, which is being that we have these functions, lambdas, or defense as we call them, and we're just stringing them together here for a sequence. That means we could potentially go and inline everything for an ultimate super long one-liner. It won't fit on the screen but you can still follow what I'm doing. So we could just make both of these into one-liners separately and then still have them like this. And we could also put them into their places, but I think it's more fun to combine them properly rather than just stringing them together. So think about it. When the result comes out of GetCount, then it gets fed into greet. And greet just does this one thing, which means if we combine all of the stuff that greet does into this expression over here, then we're done at that point. And we can do that. We can't have multiple statements because the one statement that's after we call it a guard, a condition, that's what gets returned. So we have to combine these into a single statement. But it's not really hard to do that. The way we can do it is to use the left function. So we print out this world hello, and then we discard that in favor of the argument. And that argument we use directly with this formula over here. And then once we're done with all that printing and the delays, then we're not interested in that anymore. We're just going to further print the bye-bye. And that means we've now built the whole greet function into the getCount function. We can try this out. This works, yep. That's the same. So far so good on our way to the ultimate one-liner. Now we only have one function left here, so that means we can just inline that. Can actually do that right there, like this. So now we don't have the name of that anymore. Let's try it again. Yep, works the same. And now the only thing that remains is just eliminating the line breaks by combining lines with diamonds. So we can get rid of this, and then we can put a diamond there, and then we can put a diamond there, and then we can put a diamond there, and then for good order, let's just get rid of the leading white space in the file as well. So here's our whole thing. One long one-liner onto the bitter end to the command line args right there. And let's see if it still runs. It does. There you go. A bye-bye hello world in a single line shell script. So I will post all the code online, and there'll be links to that from the description of this video as well. Thank you so much for following along.